This video explains the solution to O-Level Additional Maths 2015 Paper 2, Question 2. In the part 1 of this question, we are asked to differentiate ln cosine x. We know that differentiate a ln x, the result is 1 over x. Then after that, we differentiate the x here, which will give us a value of 1. Therefore, the result is 1 over x. We normally don't write the 1. For this case here, when we differentiate a ln cosine x, we apply the result first. Differentiate ln x is 1 over x, so differentiate ln cosine x will be 1 over cosine x. But we cannot stop there. We still have to differentiate whatever inside this ln here. Differentiate a cosine will give us a negative sine x. Okay? So negative sine over cosine is negative tangent x. And we are supposed to show this result. In part 2 of the question, we are asked to differentiate x tangent x with respect to x. So there are two variables here. To differentiate this expression, we have to use the product rule. I'm going to keep the x first, then differentiate the tangent x. Differentiate tangent x will give us a secant square x. Okay? Plus, now I keep the tangent x and differentiate the x. Differentiate x is a 1. In part 3 of the question, we are asked to integrate x secant square x dx. And we are asked to use the result from part 1 and part 2 to do this part 3 question. The result from part 2 say if we differentiate the x tangent x, differentiate this expression, the result is this. It implies that if we are to integrate this expression here, the result is x tangent x. That means if we integrate this expression here, the result we should get x tangent x. Because this is an integration, we have to put a plus c at the result here. So let's split this integration into two parts. This is a plus. We can apply the integration to this expression plus the integration to this expression. And we are interested in this integration. Hence, what we can do is we are going to move this expression over to the other side here. This is the result after we move the integration of tangent x dx over. Now we have to resolve this integration. We know that from part 1, differentiate a ln cosine x will give us a negative tangent x. So integrate a negative tangent x can give us back a ln cosine x. So here the result is plus ln cosine x plus another constant. In order not to confuse this constant here with the constant previously, I'll call this constant here a c1. This previous constant I'm going to copy down. It's nothing wrong to leave the answer in this manner, but it will be neater if we can combine these two constants together. The constant here add with this constant here will give us another constant. So we can lump this constant here and call it a k. We copy this result down and this one down as well. So k equal to c1 plus a c. In the last part of the question, we are supposed to show that the integration of x secant square x from 0 to pi over 4 should give us this value here. So now we are going to make use of the result we find out earlier on. Hence, integrate this from 0 to pi over 4 will give us x tangent x plus ln cosine x. The limits here is 0 to pi over 4. We can omit the constant because when there is a limit, the constant can be left out. Here we substitute the pi over 4 into the x and the x here. The result we subtract away, substitute 0 to the x here. 0 times tangent 0 is 0 plus ln cosine 0. Cosine 0 is a 1 and ln 1 is a 0. So the whole thing here will be 0. Tangent pi over 4 will be a 1. Make sure your calculator is in radian mode because pi over 4 is in radian and we have a trigo term here. 1 times pi over 4 will be a pi over 4. Cosine pi over 4 is 1 over square root 2. If we compare our result with the result we are supposed to prove, we realize that this expression and this expression is different. So now the next thing, I'm going to show that this expression here is actually equal to this expression. Now minus half ln 2, we can simplify into ln 2 to the power of negative half. Now what I'm doing is I'm applying the law of logarithm. The law of logarithm say this number here we can bring up to the power if this is a log. And this one I can write as 2 to the power of minus 1 raised to the power of half. 2 to the power of minus 1 is a half. And if we bring in this power half, which is a square root, we'll get a ln 1 over square root 2, which is the result here. Therefore, this highlighted expression can be rewrite into minus half ln 2 shown.